You know, what does it really mean to be a genius? Is it just being able to calculate things super fast? Or is it something else entirely? Well, we're about to dig into that very question with one of the most famous stories in the history of math. It's all about a young kid who was given a math problem that should have taken an hour, and he solved it in just a couple of minutes. Let's get into it.
So, I want you to picture this. We're going way back to the late 1700s. In a little classroom somewhere in Germany, the teacher, probably just wanting a moment of peace and quiet, gives his students a task that's designed to be really long and, honestly, pretty boring. But he had no idea he was dealing with a young Carl Friedrich Gauss.
So, what was this big challenge the teacher laid down? It was simple enough to understand, but a real pain to actually do. He told the kids to add up all the whole numbers from 1 all the way to 100. For a young student, that's a massive task.
I mean, just try to imagine doing this the long way. You'd start, okay, 1 plus 2 is 3. Then 3 plus 3 is 6. Then 6 plus 4 is 10. You'd have to do that 99 times. Not only would it take forever, but think how easy it would be to make just one tiny mistake and throw the whole thing off. That's the brute force way of doing it.
And this really highlights the two completely different ways to tackle the problem. On one side, you have the term-by-term method, just grinding through the numbers one by one. It's long, it's tedious. But on the other side, you have what young Gauss did. He didn't just jump in and start adding. No, he took a step back and looked for a pattern, a hidden shortcut that was way more elegant. So while all his classmates are scribbling away, adding number after number, Gauss is just looking at the list of numbers. He wasn't thinking about the next calculation. He was thinking about the big picture, the structure of the numbers themselves. He was coming at it from a totally different angle.
And that led him to ask the key question, the one that changes everything. What if you don't add them in order, right? What happens if you start pairing them up in a creative way? This little shift in thinking is where all the magic is. And here it is. This is the simple but brilliant pattern he found. He took the very first number, 1, and paired it with the very last number, 100. That adds up to 101. Okay. Then he took the second number, 2, and paired it with the second to last number, 99. What does that equal? Also 101. He realized that every single one of these symmetrical pairs, they all add up to the exact same sum, 101.
This discovery, this symmetry in the numbers, is the secret key that unlocks the whole puzzle. In an instant, a really long and messy addition problem becomes a super simple repeating pattern. He found the hidden order.
So let's just break down his method. It's so clean. Step 1, pair up the numbers from the outside in. Step 2, figure out what each pair adds up to. In this case, 101. Easy. Step 3, how many of these pairs are there? Well, you have 100 numbers, so that gives you exactly 50 pairs. And the last step is just simple multiplication. 50 pairs times 101 for each pair. And boom, just like that, he had the answer, 5,050. While everyone else in his class was probably still adding numbers in the 20s, Gauss was already done, finished. But see, the real genius here isn't just about solving one little classroom problem fast. The truly amazing part is that this method can be turned into a general rule. It's not just a trick for numbers 1 to 100. It's a fundamental principle that leads to a really powerful formula in mathematics. And this is it, the general formula for adding up the first n integers. Here, n is just the last number in your list, so for us, that was 100. The n plus 1 part, well, that's the sum of each pair, right? Our 101. You multiply them together, and then you divide by 2 because you made pairs. This beautiful little formula is Gauss's entire thought process boiled down into one line. So let's just prove it to ourselves. Let's check the formula with our number, 100. You plug in 100 for n, that gives you 100 times, well, 100 plus 1, which is 101. So 100 times 101 is 10,100. Divide that by 2, and what do you get? 50, 50. It works perfectly. It's the exact same answer Gauss got. So what's the big takeaway from this story? It's really about something much bigger than a math trick. It gives us a peek into what made a mind like Gauss's so special. It really shows you what the true foundation of genius is. With this one little problem, you can see the core skills that he'd use his entire life.
He could spot hidden patterns where others just saw chaos. He could use those patterns to make complicated things simple. And maybe most importantly, he could take one specific idea and turn it into a rule that works for everything. And that brings us to the heart of it all. This story shows us that true genius isn't about being a human calculator. It's about seeing the order hidden beneath the surface, finding the elegant pattern, and thinking about information in a totally new way. And that's a lesson that goes way beyond math. It's a reminder that sometimes the smartest thing to do isn't to work harder, but to step back and find a better way.